Last decade, we have witnessed a lot of Industry 4.0 innovations that focused on improving efficiency, productivity, and factory EBITDA using technologies such as IoT, big data, and robotics. However, the next wave of innovations will not only focus on efficiency and productivity, but also ensure sustainability, human centricity, and human-machine collaboration. EthAum and its portfolio startup MYWAI believe that generative, edge, and agentic AI will play an immense contribution in achieving some of these Industry 5.0 innovations in the manufacturing operations space. And that's why we are hosting a thought leadership panel on AI management systems for operational intelligence in manufacturing with an amazing panel. We have some really diverse subject matter experts on the panel today who are going to share their insights on the innovations, trends, policies that are impacting, transforming the operational intelligence space in the manufacturing. This is Pankaj Gupta from EthAum Venture Partners. We are a deep tech revenue scaler and fund based in Singapore with approximately 100 portfolio startups from different parts of the world, stage, and sector. And approximately 30% of our portfolio startups are in the manufacturing space. Now, I would request Fabrizio, CEO of MYWAI and moderator of today's panel, to introduce himself and take the event forward. Fabrizio, please.
Thank you, Pankaj, and thank you everybody for joining in. I'm Fabrizio Cardinali from Europe, Italy. I'm the founder and co-CEO of MYWAI. We have online also Riccardo Castagno and Adil Ghani from the company. And we will be presenting later on a demo and some case studies. Very good to be online. I've been in AI for a long time, since the second spring, as they call it, when expert systems went out of the market, and now it seems it's the right time for doing it. So I'm eager to get your feedback and your suggestions and hints, and look forward to a very good panel today.
Fantastic. Thanks a lot, Fabrizio. Appreciate it. Now I would request our esteemed panelists to introduce themselves. And I see Chandan on the screen, so may I request Chandan to introduce, please? Yeah.
Sure. Thanks, Pankaj. First of all, thanks a lot for having Bosch here. Super excited about this panel. Great conversations. I'm sure that that's already lined up for us. A very quick introduction for myself. I lead the digital manufacturing and supply chain service line here at Bosch, and I'm based out of Detroit, Michigan in North America. Yes, look forward to the conversation today. Thank you.
Thank you. Thanks a lot, Chandan. Appreciate your time today. Vinod?
Yeah, I'm Vinod Krishnan. I am the Chief Digital and Information Officer of the SR Group, which is a diversified conglomerate in several industries, including oil and gas, power, construction, now recently mobility, as well as metals and mining. So we have a clutch of old world businesses that are, I think, of particular interest to this group.
Thank you. Thanks a lot, Vinod. Appreciate that. Vineeth, please.
Hey, good morning and good evening to everyone. Yeah, thanks, Pankaj, for inviting me for this. So yeah, my background is I come from a group called India Innovation Center within Panasonic, and our charter is to create new business solutions. So a couple of initiatives that I am driving out over here is one is on the smart manufacturing, and another one is on the energy theme. So looking forward to this session.
Thank you. Thanks a lot, Vineeth. Appreciate it. Subbu, please.
Hi, good evening, everyone. Thank you, Pankaj, for having me here with this team panelists. My name is Subbu Swaminathan. I work for Rakuten, one of the global conglomerate from Japan, with 70 different businesses, starting with e-commerce, travel, payments, logistics, one of the key where some of the manufacturing related things we apply to, and really excited to be part of this and knowing more about everyone.
Thank you. Thanks a lot, Subbu. Appreciate your time. Sachin, please.
Good evening and good morning to all. My name is Sachin. I'm looking after basically I'm from the Solar Group of Industries. They are basically the manufacturers of the explosives and the defense and military equipments. I'm leading the supply chain management here, and I'm also leading the digital automation and research team, which is basically an innovation cell here. Primary focus on how we can utilize digital technologies in our day-to-day activities, how we can make our manufacturing processes more digital. And we are also working in the space of something called as the smart manufacturing, where you are working on the digital technologies, particularly the LLMs and the agentics AI, and how we can bring all the capabilities of the Gen AI into the manufacturing. Thanks, and looking forward for this discussion.
Fantastic. Thanks a lot, Sachin. I see that quite a few initiatives at your end are extremely aligned with what MYWAI is doing. So appreciate all the panelists' time today. And I know Fabrizio has prepared some really interesting questions for you. So I would request Fabrizio to take out those questions and get some hot sizzling takes from our panelists today. Fabrizio, please.
Thank you, Pankaj. I think I would start with Chandan from Bosch, because we are Europeans, so we know the reality, German reality. Bosch, headquartered in Germany, but global player very well. I think we all grew up with the "Live Like a Bosch" advertising, which is now coming to the different nations here in Europe, where you see a pervasive presence of IoT and smarter machinery out there. So that's really aligned with our vision. And actually, we also work a lot with Bosch because we are incubated by the Startup Harbor program of global innovation from Bosch Group. So we know the reality very well. And we think you are the ones which have witnessed the migration from OT to IT at this very length. So today, there's a bridge which is coming out so that the data coming from machines and plants is not only siloed and closed, but it's actually starting to go outbound to IT service providers, which are not going to be only technical, but also banking, finance, payments, insurance, and so on. So it really seems an ideal playground for AI, where you could use generative multimodal agentic AI to do the next step. So what is your vision in Bosch and your personally take about how these new technologies and AI particularly can really change the equation of OT to IT integration today?
Yeah, great question, Fabrizio. In fact, if I just break this down into two parts, if I look at the key challenges that we are facing, and some of these are very traditional challenges. We have come a long way, but we are still struggling with some of these things. Different plants, different OT systems that we operate at different levels of tech maturity. Some of them are state of the art, best in the class IT systems or OT systems that are being used, while we also have other systems which provide a very opportunity-rich environment for us to do more on the digital front. So I think you also mentioned that breaking the legacy model where OT systems are going to put data only onto their MES and the SCADA systems and not move a lot of this data to the northbound systems, the enterprise IT systems, is something that we really need to break. And I also very strongly feel that AI has got a very strong role to play there. A multimodal data analysis, you spoke about it. One thing that we have realized is it's not just machine data, it's also data coming from different sources like sensors, your video camera feeds, and so on and so forth. So when you have a very multimodal, a very, very diverse set of data collection mechanisms, you need to have a platform that can understand all this data and create a more, and I'm going to introduce this word of contextualized intelligence or contextualized insight. It's one thing to know where you perform, but how do you flare that performance to, say, the state-of-art systems or the world-class systems? And can these systems suggest what are the ways you can improve your existing systems, identify those bottlenecks in your existing systems to help improve them? Is something that I believe AI and generative AI is going to have a very strong role to play. Predictive maintenance, process optimization, very common themes that have been spoken about and have been discussed for years. But when you're talking about OT systems which are so diverse, can you really bring that kind of intelligence onto a platform that can help people plan their manufacturing systems well in advance? A very underrated aspect around cybersecurity improvements. Oftentimes people, and if you just look at it, we are constantly looking at around 19 to 20% increase in cybersecurity threats, especially in the OT segment year on year. Huge area of investments. Can we have AI systems, generative AI systems, identify risk scenarios, threat scenarios in the OT systems, and go about making those recommendations so that we can fix them in advance as well. So right from the point, which is usually an assessment process, which is done maybe once every quarter or once every 6 months, can we have a real-time on-ground assessment systems being run by generative AI models that can help you identify what are those risk standings that you're looking at, and how can you go about improving or eliminating them to the maximum extent possible. So I think huge play for AI to come in and solve some of these very critical problems. Interoperability, another big challenge in the segment. We've got machines that operate on different protocols. Can we have generative AI start coding the middleware that can help integrate these diverse systems together to bring a common set of intelligence on your entire process manufacturing space? So yeah, lots of thoughts to share, but I'm a strong believer how AI can help us solve some of these critical challenges that we are looking at.
Thank you, Chandan. Yeah, you're surely coming from the solution space, and we see ahead a little bit of what we would like to propose to the market. But where are the real players sitting today in terms of solutions and solving those problems? I would like to ask Vineeth, from Panasonic. We grew up hearing a lot of good music from your systems and many other stuff. So you are one of the very well-known producers of goods, both in the consumer and professional market. So, how do you see AI coming into your plants and production, doing quality control, goods, so quality check before you release them to the market, and eventually also helping you maintaining those machines once out, because the other big business is that even the consumer goods will become smarter and smarter, and you can start putting chips and boards like this one, which has got 5,000 neurons inside a good, and start doing some AI at the very edge inside the machinery and the equipment and the appliances that you're selling, making a winning differentiator against your competitors. So what is your take on this AI incoming phenomenon, Vineeth?
Hey, thanks, Fabio. Thanks for the question. So Panasonic, maybe for the outer world also, just to know that we also manufacture a lot of industrial equipments, like our surface mount machines, which are used for the PCB assembly boards. We also manufacture this robotics welding machines and all. So we understand this industry from a decade ago, and we understand how this manufacturing industry operates. So bringing in some of this new age solutions and addressing some of these core problems is something that we have taken a leap into this. And coming back to your question about how IT and OT convergence. So yeah, so most of the organizations usually have a very good IT kind of a network, and OT is something which is catching up, where you're trying to connect your different assets, you're trying to digitize a lot of things on your shop floor. Now, how do you marry both of this data? Because most of your upper end systems is doing all your productions. It has an idea about what is your inventory, all those kind of things and all. And the real thing happens on the shop floor. Now, how do you convert this data so that intelligently you start understanding how to optimize and use your assets based on the production that you have to do every month, kind of a thing? How do you understand your machine's behavior? How do you predict the failures of your machines and optimize it in such a way that your productions are not hit because of some of these failures and all? So generative AI is definitely going to play a role into this. Right now, I call this jargon as DRIP, which is data rich, information poor. How do you try to make the data that is coming in and trying to get more insights and trying to get more information from your this? So that is where I think generative AI will start playing a role into this. Simple use cases that we are seeing is like on the shop floor, there are so much of data that the operators are looking at. Just look at the manuals that they have to go through when they have to fiddle with some of their equipments and all. How can a generative AI just give some insights about looking at those manuals and just give some basic insights about how to operate their machines, or if there is any failure, how to go about debugging those things and all. So some of these things could be very obvious case, but yeah, there are complex things like things of doing predictive maintenance, trying to understand the failure even before the machine is going into failure. So this is something that I would say that it's a combination of different things. It could be like a multi-model thing where you have data coming in from your assets, but it could be also some kind of video feed which is coming along with this, how do you combine all these things together and form a good insight so that you can predict the failure even before it is happening? And there are significant kind of losses that happen in this industry because of these kind of failures and all, and how you can address this. So I definitely feel that the new age technologies and all, whether it is generative AI, how they can address these kind of problems is something that every organization should look forward to it. Another aspect is looking at the kind of quality issues that we see from products that are coming out from the factories and all. How do you address this quality issues? How do you marry these issues so that once you have understand about it, identify the potential issues that are in your process, because the quality could come because of your how is your process being utilized. So there are various number of things due to which the quality can go bad, and there is a lot of data that is coming out from your systems that you can understand about it and then take necessary actions on it. So, and another aspect also is to look at how the industry is maturing, at least in the automotive sector that we see is that any part failure that is happening in the field, how easily you can trace back and understand from which factory or which plant, which assembly line, to which machine, to which operator. If you can trace back this whole thing, it's so easy for them to identify the root cause of the problem and not disrupt their whole supply chain because of this. So how do you intelligently understand all this data and take those necessary actions and all? It's where definitely I see this AI playing a big role. And I definitely see this industry taking the adoption of AI more than any other industry, because this is something which I would say that the manufacturing industry will show the step forward in how to do the adoption for AI bigger than any of the other industries.
Thank you, Vineeth. I love your DRIP acronym, so data rich, information poor, and your insights on how generative multimodal LLMs can actually help to solve some of that poorness of insights. We are doing cases where LLMs can deeply analyze the standard operation procedures and help chatting with maintainers and people having to do with equipment and appliances. We see multimodal streams coming in, not only text, but also video, audio, giving you additional information about actionable insights. And last but not least, we use generative for generating effects, because a big problem is that production is huge with problems of production defects, but the companies don't give them out, don't actually have those data recorded, because it's much more fancy to record good production data than wrongly produced assets. And so generative AI can be used to synthetically recreate those defects. So very good insights on this first technical take about OT and IT integration. I would now like to switch to Dr. Subbu from Rakuten. I've discovered Rakuten in preparation as a huge, correct me if I'm wrong, Japanese headquartered company active in banking, insurance, and anything which is commerce today. And we were exchanging some notes over the web in preparation, and we were agreeing that as soon as AI becomes more trustworthiness and with more explainability, it will start entering even diverse sectors, not only the technical solutions that we are talking about, but additional things like pay-per use, pay-per performance, insure per event. So banks, insurers will start getting into the equipment data as a brand new business. And there are new regulations coming out. We'll talk about that in our presentation in the European Commission, which is closing quite a lot the European market, but they're opening up for data monetization. So what is your take on that? And how do you think that trading data from machinery could actually happen in the next future?
Thank you, Fabrizio, for this question. I think I'll address it in three parts, right? One is around the current AI adoption and challenges, especially in manufacturing. I think there is significant potential, like the previous panel speakers spoke about, predictive maintenance, process control, and things, and machine efficiency. But the adoption is very slower because the trustworthiness, the safety, and the transparency has been the challenge. And like you talked about, the EU new AI Act is also adding additional regulatory complexity into that. So that is where it's going to be, very, very important how the data is, collected as well as processed, and how the operator get to understand the interpretable of the data and insights. That's going to be very, very important in that aspect, right? There are some examples around Siemens MindSphere IoT platform and things, but then still the adoption is very slow at the manufacturer because they don't want to put this in a critical, operation, right now to do that. Now, coming to potential business models, definitely there is a lot of opportunity with AI coming in here. I do see the equipment as a service. Many manufacturers going in right now. The adoption of AI is still very, very at the early stage. There, companies like Rolls-Royce, where they do power by the hour for the jet engines. It's a classic examples, but still, we'll have to figure out what is happening. Pay-per-use opportunities, like some of the companies like Kaiser Compressor, which is also using compressor air for as a service, and they're actually using AI to optimize the performance, right? And finally, you talked about the insurance aspect, the bank and things. I think this is something which definitely I see a lot of promising opportunities for AI to, in fact, bring in finance, insurance stakeholders onto the table to really see how kind of AI model, as it get matured, as it get more accurate, more reliable, how can this be used in order to look at the operations and then seamlessly see how they can potential improvements can happen there. Finally, I think you also mentioned about explainable AI, and how do you use the AI, explainable AI, on the edge base and cloud base. There is definitely an opportunity where significantly most of the edge-based explainable smart edge IoT solutions, which can be very close to the operator side and provide real-time analytics and real-time insights, while the complex algorithms and LLMs can take cloud-based approach essentially. So both of these going to play hand in hand in order to generate real-time solutions which can impact lot of savings in the manufacturing as well as the entire manufacturing life cycle. I see this is going to be an interesting domain, like Vineeth said. Definitely manufacturing is in its prime for innovation there, and adopting it first and then leading the industry, I would say.
Thank you, Subbu. And I would like to go now into Vinod experience from SR. It's a huge conglomerate, industrial manufacturing conglomerate. So, you presumably know better than many others what are the issues in adoption of these new model, and actually even getting AI inside your operations, given the current stages of security and trustworthiness of the AI systems, and presumably they need a little bit more security, but at which extent and in which specific points you see this happening.
Right. Thank you so much, Fabrizio. And I think Subbu has already covered, a vast part of the landscape. So I will try and hit upon a couple of areas where I don't think, we've touched on sufficiently in the course of the discussion so far. One of the biggest challenges I have found, and I've worked for a number of operations intensive and manufacturing intensive companies, is really the, for want of a better word, the lack of transparency when it comes to metrics around manufacturing, particularly in areas like breakdowns and downtimes. Sitting in the management committee of several of the companies involved in this, it's seldom that you see an accurate RCA. Because of the number of variables that are involved in potential breakdowns, the tendency is not to analyze. And the other part, which I believe strongly, and I don't know how I've worked in Europe for the better part of 10 years, 5 years in Germany and 5 years in the Netherlands. And I don't think it's any different there, that to a great extent, manufacturing is run by experts. And it's very difficult when you look back at it, because much of this expertise is intuitive. Much of this expertise is experiential. And challenging that, especially in a management forum, is not an easy thing. The head of manufacturing of most of our companies will tell you, I've been on the shop floor for 30 years and, this is how it is. And to a great extent, when you bring in something that is data-based, when you bring in something that itself from a theoretical point of view is not intuitive. The adoption challenge is really how do you co-opt, how do you bring this magical tool into the world of manufacturing experts who believe that, a lifetime of experience gives them the ability to understand this. Of course, we all understand in this group that mathematically you don't have formulae to figure this out. If you did, you won't need, you could do this with conventional programming. And we also understand that the number of variables and the number of data sources is huge. And most of us believe that if you have a model that does a reasonable job of predicting, even marginally better than what you have today on the ground, that you have a huge business case that is only getting exponentially better as the model gets better. But it's my view that part of the problem or part of the solution is also how do you bring in manufacturing leaders into understanding this science? Is how do you bring key stakeholders? How do you bring pressure? For instance, if I got my CFO interested in how this model actually is going to bring down maintenance costs, so you might have a head of manufacturing who's not too concerned about the IT or OT part of his environment. But steady pressure from the rest of the management committee is a great way to drive adoption. Because if the numbers say that this is what you're going to save, then that creates a pressure, a positive pressure, in my view, through the value chain to drive adoption. So a lot of what I believe is really that have the data, have the people from manufacturing understand models, have them participate, have them get into this themselves. If we do this as something that's come from outside, this is not likely to take root natively, but much more to say, can we simplify, can we explain, can we make transparent how the model works, can we not oversell it, but put it in perspective as a need? Can we then perhaps bring expertise to further explain and further codify or further improve some of the models that we come up with? I think that is really the frontier for me as far as adoption is concerned, because it's one thing for the technology to work and for us to get to better prediction rates than what we've been doing so far. It is completely another thing to have our manufacturing colleagues and our supply chain colleagues welcome and accept the technology and use it to its fullest in making operational decisions on a day-to-day basis. I think what Subbu said about products and as a service, this is a concept that I think as a consumer of technology and services, we love. Diesel generators by the hour, everything by the hour, everything by the minute. And I come from telecom, where we went from billing every minute to billing every 30 seconds to every 15 seconds to every second. And I'm not sure that there's somebody who's billing in fragments of a second right now. But that is really the future. And I think enabling that is going to be really huge, because that raises questions. How do you price it? How do you balance your load? How do you optimize for revenue? And these are, I think, great problems to solve with a great tool that we have. It's just about how do we apply these and how do we market it well to the stakeholders who really can make it happen.
Thank you, Vinod. Very, very good insights. And I would like to bridge it with Sachin into, going back to the very core, hard part of the industry. I've been studying a little bit solar industries, and they're a huge conglomerate and very, very difficult and risky businesses, from blasting to mining to hydro construction, building. So very, very hardcore, let's say, activities. So it's very intriguing to understand how a very, I would say, solid rock activity like yours actually start considering and using AI, and how core is the security and trustworthiness of that technology, and eventually coming to the things that we try to offer to the market how relevant it is to have a centralized AI management system so that all your data, all your operations just go here and there on thousands of PLCs and different systems, but they are actually concentrated into a legacy, which is going to be presumably the future value for every single industry. Because if you have the data and you have the knowledge, you need to, and you can turn them into actionable insights, actually the value of organization is going to be, increasing a lot in the next future. So how is this actually managed in solar industries, and which state of the art do you have in AI? You're muted.
I'm audible?
Yep, please go ahead.
So a very good question, Fabrizio. It's like this, we normally have the Industry 4.0 implemented in various organizations. We have integrated the SCADA system. We have integrated the entire PLCs, which include production data, which include quality data, which include utilities data, which include environmental data. We have bring all this to a single dashboards. But now what is happening is that this single dashboard is good for taking a decision when we are looking at it. But a lot of, as rightly said by Vineeth, the DRIP concept, that is data rich and information poor, right? But the information we are not able to gain from it, right? So it's very important that if we can able to bring some kind of the intelligence, some kind of the AI, where we can integrate all those data, because it's relatively difficult for the team to integrate all this data, whether it's SCADA data, whether it's the MES data, whether it's OT data or the supply chain data. So it's very difficult for an individual to bring all these data and analyze it individually. And for that, I believe that AI management systems can help us, particularly what we talk about the Gen AI part, where we can bring all the data from the different sources, whether the data's and somehow we can prepare that pipeline, data pipeline, where we can bring all those insights, all those data on one single platform. And then we can use the knowledge graphs and fine tune all those data to get the information, get the insights. So I believe this kind of the AI strategies will help us in getting data integrations and accessibility, because we can consolidate data from various sources, maybe in a unified system that will provide us a holistic view of our operations, right? This integrations allows for seamless access to a real-time data, which can help us enable us to take up better decision making and give us the faster response times so that we can take up all the operational challenges. Secondly, as rightly said by one of the panelists, particularly with respect to the predictive side of it, right, where we can unify all these AI management systems, particularly the Gen AI or the LLMs, where we can leverage those potentials of those advanced analytics and machine learning algorithms, so that we can analyze those historical data as well as the real-time data. This will help us in predicting what is the failures, equipment failures are, how we can optimize our maintenance schedules, how can we improve our OEs, overall equipment effectiveness. So this can be help us when we integrate all these AIs into our data. Also, this will lead to the improved decision making, because particularly the generative AI will help us in the scenario plannings, particularly the simulation type of the things, where we can able to explore what are the various operational strategies and their potentials are, so that we can impact those implementation. Also, it will improve the operational efficiencies also, because we can automate a lot of routine tasks, okay, and particularly the processes also, where we can reduce all those manual interventions, and and by the way, we can reduce what are the likelihood of the human errors. And also last but not the least, I will talk about something called scalability and the flexibility, because integrating AIs in our data will help us in a unified AI management system, which can be scalable, as well as it will provide the flexibility so that we can help the business in their business. I mean to say, change whatever the changing business needs are, and how we can use those technological advancement. So these are few of the pointers from my side, Pankaj.
Thank you, Sachin. I think we did a first very good roundtable introducing all the single panelists and their huge background, both personal and company-wise. I think that Pankaj, best time would be now to maybe give you an insight of what MYWAI is bringing to market. So to trigger our Q&A, we call it roast session because you actually ask to be very provocative, either positive or negative, or critiques as good as good things. So to trigger that, maybe if I could share the screen and give you the presentation, and then we'll take it from there. Is that okay?
Thank you. No, that's great, Fabrizio. Let's
okay.
Go through the presentation. Yeah, please.
Do you see the screen?
Yes.
Okay, so we come from that world. I mean, I've been working personally for a long time in the service industry, the publishing industry, where blockbusters and Dava just blew up because they didn't see the light of innovation coming over. And I started to work in manufacturing with former Siemens managers during 2013, 2014, and we were seeing this revolution coming forward. And I stayed with this Siemens big group, a group of managers up to 2019, 2020. But then during COVID, I decided to quit and to actually do what I was seeing a solution for the upcoming Industry 5 world, where it wasn't only actionable insights taken by humans, but actually an artificial intelligence capable to actually analyze the data and give you some insights. So off I went and I founded MYWAI, and we built it together with people coming from the industry and manufacturing. And the elevator pitch that I would like to summarize why we did the company was actually to help become the machinery and equipment become smarter. Today equipment is still very dummy. It breaks a lot. It works quite awfully sometimes. And if there is something that AI could do very good, is maybe more than increase human beings, is actually increase the machinery, which is, as I said, much more dummy than people. So we thought that that's what an ideal place to play. And we started to actually invest and developing in this direction. And somebody's already talked about, the new business and service model. So it's not only going to be a technical solution that it wasn't going to be only a technical solution that we were thinking of, but also the convergence of new services coming from finance for paying the machinery itself, or insurance, actually for insuring the goods. There is a Deloitte, which is actually arguing that in 5 or 6 years, all the industry of manufacturing will go towards services. So that once you have connected machinery, and today you have to connect machineries because they need to be very, very secure and updated continuously due even to new regulations coming out. So at that point, they are online. So it's worth giving them also the ability of delivering new goods and services. And this is actually going to be regulated in the community, European community, with a new act, which is not only addressing AI, but also the freedom of interchanging data coming from machines. And at that point, there will be a lot of players brokering the information across different providers and consumers of such data. So that was the vision that we had when we started MYWAI during pandemics. And we were quite lucky to get a lot of investment from the European Commission, from the European Space Agency to technology. And today that we are delivering the system, once that's been developed and tested, we see smarter machines coming out more and more every day, not only in very critical assets and very critical infrastructures like plants and smart cities, but also enertech fields and ports, even new markets like those producing electrolyzers and green hydrogen, up to clinic and hospitals where wearables and machineries are getting more and more connected and starting delivery new services and new goods on a continuous basis. So it's really a revolution that is happening while we are talking. The ecosystem around these machines is getting more and more broadband and connected, and the machineries are getting more and more intelligent. able to hook up. At that point, it's quite evident the services that you can deliver, starting from the most traditional ones, being able to reduce the downtime of machines as you're going to pay for the deployment at the first or second iteration quite easily, because we will see the data, machines break down very often, and just a couple of minutes stop in an automotive industry is worth millions of dollars collectively in the US for a year. The other big market is quality control, where you can actually go online and verify and certify the goods that you are producing, down to energy saving, which is another big buzzword of the moment, where you can actually study the consumption behavior of your machinery and maybe pay the grid and pay the energy at the optimized timing. And last but not least, the new frontier, which are not only controlling machines in terms of quality of their production and breakdown times, but are you also feeding back control with AI agents able to control, instead of PIDs and other controllers, how the machine themselves work. So we start with very traditional markets, 50%, 80% of our implementations are dealing with predictive maintenance. I was summarizing the numbers before, huge breakdown time, cost. This is just for automotive in the US, so 50 billion a year cost just for those minutes that the machines stop in automotive sector in the US, and huge cost for missed quality. So the missing quality cost is huge. It's averaged up to the 15-20% of the overall cost of sales in manufacturing. So there's not only production and business issues here, but people can also get injured by wrongly produced assets, and so quality inspection is another huge market. And when it comes to electricity gains and electricity optimization, efficiency of the manufacturing machines, there's a lot of regulations coming out worldwide, where you've got energy credits if you are able to certify, maybe on a blockchain, that you're actually consuming less from the grid thanks to optimized usage of the machine itself. And that's all, I wouldn't say bread and butter, but you're surely seeing this in your organizations, tackling it from different perspectives, POCs up to big systems, working or more or less effectively, but this is all quite well known. What's happening while we are talking is that these things are getting even more nested inside the production processes. So we are seeing the emergence of what is called agentic AI, where AI is not only able to get data and analyze it, but these data are becoming multimodal. So as we were saying before, you can also hear from a production line what sort of defects are going on. You can see them with thermal cameras, touch sensors, or whatever, or you can have time series, and blending these together are much more effective as insights to machines, to machine learning, than monovariate streams are. The other things they're able to do, these agents are starting to reason. So they're able to do things like chain of thoughts, which is getting very, very popular with the new ChatGPT outcomes. You're actually able to take some sequencing if then else approach to the things that you're sensing, and also using external tools to actually do the sequencing of your decision taking. And this actually means a very clever AI, which can be put together with humans in the loop to control machinery and what's coming out. And the next steps are going to be physics, maths, informed information, spatial intelligence, and so on. And this is what we're working on in MYWAI. So we are adding to the platform the ability to control machinery. So for the Stellantis case that we will see, we have reasoning agents which are substituting PID controllers. PID is, for those of you in manufacturing, are those systems talking to PLCs with regulate valves, pumps, or anything in a plant using proportional, integrative, and derivative laws. But they are quite fixed laws. So if something changes, like there's an electrode which wears out, or if you're actually welding two pieces of materials and the line of welding differs a little bit with what is expected by the law, the laser doesn't actually weld optimized as it should be. So these things can be controlled live by a robotic agent, which actually sees what you are doing with the machine. Is actually how the machine is performing. And if you give it rewards, it's able to learn the law of what is actually controlling much better than a PID. So reasoning agents are coming to market, and these reasoning agents are starting to learn physics and maths. So, you're presumably using computational fluid dynamics or finite element analysis in your designs, in your buildings, in your machinery. But those softwares are very costly. They are, with errors because it's a finite analysis, and also they are very latent. So it takes a lot of time to actually do simulations. Now, AI is not only learning text or sentences, it's actually learning physical laws like Navier-Stokes and others, so that they can actually create digital twins which have got a soul managed by AI, which is able to actually react to the changes that humans are giving them while they are operating. And this can happen, you see it up here in the left corner, high corner, it happens much faster and with a much better accuracy than traditional FEA softwares or CFD softwares. And that's a big convergence for mechanics and hydraulics. So you're actually merging the traditional world of modeling with agents which are learning such models without the need of actually modeling too much. You're just measuring the input output of your ecosystem, of your machines, of your process, and so on. And so the very next step that everybody's talking about is all of this learned by machines in the environment where they are working. And since the work environment is actually done for human beings, the robotic revolution where robots will learn this more and more will happen overnight while we are talking. And that's quite easy to imagine by what's the latest announcements from the robot producers and manufacturers. So we're doing all this in MYWAI, and why should you come to MYWAI with so many offerings out there? Well, first of all, Europe and Italy and Germany are very, very strong in manufacturing. So these are studies from Google and Amazon, which actually say that the day-by-day use of AI is actually at its highest stake in Italy and Germany, where other markets like the US or the Asian market is more sitting on fences to actually see what's happening in this sector. And this is also from Google. So we have Google and Amazon studies on cloud, which are actually stating that if something new is going to come out in the consumer market, it's surely going to come from the American market, from the US. But if we're talking of manufacturing, there is still a play for Europe to play its role. And it's a huge market. So it's only talking about equipment as a service. These are estimates. And if you think of servicing devices, appliances, equipments out there, it's going to be a very big market. So we set up this company with a lot of funds from the European Commission and the European Space Agency, which was interested for, let's say, satellites, for example, which is literally a very good market for intelligence and putting intelligence on machines. We have been growing from very small zero in 2021 and we started operation in 2022, and we grew up to more or less $3 million. These are euros. And we are now doing a round A for positioning our company in Asia Pacific, and we're talking with EthAum for that out of Singapore, and in the US on the Midwest, the Rust Belt for the American market. We are headquartered in a very, very attractive site. This is Cinque Terre, between Cinque Terre and Portofino. It's a silence bay of Sestri Levante. You might have come here hiking in the northwest Italian Riviera between Tuscany and France. And we have 500 square meters in this sacred abbey here by the sea, doing AI, blockchain, and IoT convergence. And this is where we develop the technology. So we have this MYWAI AIoT management platform, as we call it. It's actually the first machine independent, so we can actually hook up to any machinery with zero code, no development, using standards like OPC UA or MQTT on the fly. And it's multi-cloud, it works on any cloud solution. And the good thing is that we have an open interface to upload any existing algorithm. So we have more than 50 algorithms inside the machine, but we actually can upload using Docker or Python, or we've got even an open marketplace where third-party players can put sensors and link the algos to work either on the cloud or on the edge. So what we do is we actually stream up millions of data. We create the AI pipeline of choice, which could be for maintenance, could be for energy saving, could be for quality control, but also we have APIs for banks and insurance if they actually want to make payments or insurance on top of the machinery itself. And then we push things back optionally to the edge. So when it comes to the edge, we have, interface and agreements with the main edge providers from Beckhoff to Advantech to Aerotech. We also have our own edge, but the good thing is that we can also have very slim and performing boards which accelerate the algorithms directly at the very edge, near a camera, a turbine, a robot, or an echographer, as you actually want to do it. And on the back end, what we do is we use standards to actually expose data backwards into the cloud for those which want to provide services. It could be internal departments, as I was saying before, it could be insurers, payments, legal debates, especially in highly critical infrastructures. We have a blockchain, which is one of the 3 things that we have merged. We have a IOTA blockchain to certify all the data which lead to eventual malfunctioning problems into the plants and machinery. And if something blows up, for example, you can know, track by sensor X at time Y, where it happened and due to which eventually which caused the malfunction. So it's got different modules, cloud, edge, and blockchain, but I'll skip this. For the technical guys, it's a multi-cloud Kubernetes and Docker-based infrastructure, so it runs on any cloud. It can be installed behind a firewall on premise because there's a lot of very critical and sensitive data that people don't want to give out. So it's a white label like infrastructure that you can import inside your infrastructure and manage all your AI projects, or you can use it on a paid seat basis into the cloud. We'll showcase a little bit of scenarios and case studies. This is the interface for the Stellantis group, the automotive world leader, where you can see, you can actually configure your machines, your sensors, your equipments. You can import massive amounts of data, either from Historian or from live machinery connected to the MYWAI infrastructure. You can load your algos, either using Python, Docker, or an open marketplace, and then off you go to actually deliver orchestrated intelligence, either on the cloud or at the edge, using a software edge, which is able to create the data streams and actionable AI to take the actual feedback to the cockpit. We've done a first traction of the system with world-leading players. For some case, a lot happen to be Japanese, but there's a lot of also European and American players that we are talking to. For Mitsubishi Electric, the world-leading in many things, but surely in robotic fleets. What we are doing, we are creating a portal for tracking all their robots on the ground, analyzing equipment efficiency in terms of vibration of the joints and problems. So it's a technical OEM fleet management infrastructure that we're setting up for them. For the world-leading biomedical machinery producer EthAum, which is held by a Chinese group, but it's actually producing in Europe. In Italy, we are doing all the management of ultrasounds and magnetic resonance imaging systems, and we are detecting failures of probes, and their servicing is actually opening tickets based on the intelligence that we are using near the machines while they are operating in clinics and hospitals. For Hitachi, we are doing smart cities control of vision systems, not for headcount or for train occupation. They already had that, but they wanted something very near the camera to detect if they were under terrorist or vandalic assault, and they want to see if the cameras are broken or with FOAM or underexposed. And they don't want that to work on the cloud, because if somebody cuts the wire, you need to detect it. So what we used here is a lot of generative AI for creating these sample images. This is not a real image. It's generated by a pix-to-pix Gen AI algorithm. And by using these AI generated, we train the edge to actually detect different defects of the camera system. Hilex, it's a world-leading manufacturer of window lifters. It's one of the two in the world. This is Japanese. The another one, I think it's American. They create electrical engines for the window lifters, and they've got a lot of problems because the workforce is getting older and they're not able to detect malfunctioning window lifters. So the quality check is getting issues, even because with electrical vehicles, the rumor is going down. And so they're not able to detect it. So we put an electronic air managed and powered by MYWAI together side by side to the human to learn his ability to detect defects. And we're talking with the SCADA system to feedback correctness or incorrectness of the production so that they can eventually move out the production on those which are wrongfully assembled. Last but not least, what we will be showing today is the key market of intelligence when it comes to very high-end sectors and multi-physics sectors like welding and energy production. So in the energy, is in the welding sector, we are doing control of welding machinery from arc welding to spot welding to laser welding. Laser welding is a hugely complex multi-physics process, and the machine that we are interfacing provides us millions of data, but we're also adding acoustics and vision to detect if the welds are correctly performed. And last but not least, we are doing an agent which is actually lively controlling the welding of robots in the production of e-batteries for the Fiat 500 in the market. And the last sector that we are engaging is in electrolyzers and energy production. So with Ansaldo, which is a world-leading producer of turbines and electrolyzers, we are not only controlling the efficiency and the maintenance of the equipment itself, but also going towards metrology of measuring the manufacts they are producing in terms of turbine buildup, and controlling the process of electrolyzing. So very hardcore, I would say, process in that. The demo that Ricardo will do, but I will take some questions before entering into that one, is going to show you, interfacing with welding machine, a world-leading Austrian Fronius machine, where we take up all the data and we do intelligence about the welds. In arc welding, we will then see some spot welding where you have machinery like this one, which is actually joining the parts of a white body in an automotive market. And again, we are controlling the quality. But last but not least, the most important one, as I was saying before, is controlling the welds of batteries, where things are very, very complex. So it's a multi-physics phenomena, and now it's regulated by a PID controller. We are putting agents. So we are developing 3 agents. One is for multimodal reasoning on top of the quality of welds, not only hearing the acoustics, but also the data from the machinery, the movement of the welder, and thermal vision of the weld itself. Then we're using it in generative AI to produce the specs of the welds, because they are always quite limited in terms of what they give you to train the algo. And last but not least, as I was saying before, we are doing a plug-in toolkit for an agent which is able to control actually the welding process in line, doing it much better than traditional PID-driven PLC controls, usually managed by the Siemens and Rockwells of the kind. So I think we are on time. I would go for a session of Q&As for those who want. And if Pankaj, you can help to switch the microphones and the cameras, I'm more than eager to actually answer the questions at this theoretical level. But since a demo is worth 1,000 words, and we're really doing what we're talking about, Ricardo, if we can save some 10 minutes towards the end, he will do a demo, and we can take questions even after the demo itself.
Yep, let's take some questions. Panelists, please feel free to unmute yourself and ask questions. Yeah, Vineeth, please.
Yeah. Fabio, on the multimodal welding this, right? One question, will this work if it is not a multimodal? If I just rely on the machine's parameters from the welding this?
Yep. Let me bring it back up so that I was a little bit faster, presumably. So if you just give me a second, I will try to. Okay, if I go to this slide down here, I'll explain it, even if we'll see it in the demo. Here it is. So, okay, so it's actually a truly multimodal. So we take all the data from the Fronius using OPC, and that's machine data correctly, multivariate, but monomodal. But we are also adding audio. So we've got acoustics coming in because we have learned by the welding experts that you hear cracks where oxygen gets into the mixture of the welding and more or less cracky sounds good or not. Then there's the movement of the human welder. We've put an EMU, an accelerator on the wrist of the welder, so we're measuring the movements, and then we've put thermal cameras, and we're using a multimodal AI model from Meta, which is image bind. It's very interesting because it binds everything to an image, so it binds text and image, video and image, movement and image, thermal and image, and it emerges new links across the sensors. So you can give it an audio and it actually retrieves the EMU. You can give it an EMU and it retrieves the audio according to the classification. So it's a multi-sensorial classification. We're going to use this to retrieve similar welds for the certifier. We have a world-leading institute of welding, IIS, which is going to test the system very short term. We have developed this Ask Walter, which is a welding assistant, which will be working inside the mask of the welder, and it's truly multimodal.
Yeah, but coming back to my question, the reason why I'm asking is that if I have to go and deploy this solution, there are a number of things that we need apart from gathering the data from the machines, right? So I was trying to understand that, does the accuracy of this system go down if I say that I will just use the vibration and the machine data?
Yeah, very good question. We have developed it initially only on machine data. So we only use the Fronius data, and we will see in the demo a classification, which is this reddish and greenish here, is done only on the machine data. And now we are extending it with the other sensors to cross, to check how the improvement is. With this one, we've reached a 92% of classification of welds, and it's working fine. So it really depends on what is the setup that you're thinking of. Acoustics is quite easy to couple with machine data. I agree that movements and thermal camera are both most costly and more research oriented, but the two, audio and acoustics, is quite far for having a multimodal effect.
And how easy it will be to replicate this on any other OEM's welding machine?
Very good question. We are testing it with a couple of different vendors, and it seems that the acoustic and time series binding is working perfect. The multimodal part, we still have to test it across machines, so we're just doing it on the Fronius for now. But it's the patterns. The good thing is that the Meta image bind solution improves classification related to the monovariants or to the monomodal algorithm. So it's witnessed that if you add sensors, even the traditional way of classification works much better. So we are thinking of doing set up a station which records all the welds multimodal wise, and then we're going to downscale it to single single data to see how much we lose.
So the output is what? It identifies
it classifies. This is IIS is a certifier of welds. So those people coming in, and when you are welding bridges or ships or anything else, they certify the correctness. They also do how you say, non-invasive test by ultrasounds and magnetic fields. So they've got a very good ground truth. And the output of this system will be generating reports. So we're going to binding also an LLM for generating reports of what's actually seen and submitting it to the certifier to have it certified on blockchain with the support of an agent. So it's going to suggest reports, a little bit like things are happening in medicine where AI is used to do a second judgment of the human being. So the human being gets triggered if something is wrong, and it gets some sort of support in the classification of what needs to be classified.
Sure, thanks.
I think those were some really interesting questions from Vineeth. Thanks a lot, Vineeth. Do we have more questions from other panelists? Please unmute yourself if you have any question in your mind. Yeah, Subbu, please go ahead.
Fabrizio, very good presentation. I have a follow-up question related to the new EUA Act, right? And while the solution seems to be, inclusive of a lot of use cases across manufacturing and things, how are you seeing the new EUA Act, and how are you integrating that with the solution to provide transparency as well as risk-based scores and things? This is something which I see EUA Act is, specifically enforcing in terms of, high-risk systems, how is the risk is assessed, and what kind of transparency is provided to the, end users or the company using it.
Thank you, Subbu. Very good question. Europe is sometimes wrongly famous both for the GDPR and the EU AI Act that everybody's talking about, simply because it was the first in the world to react to nonsense usage of personal data. And we would all agree that GDPR eventually late, which was a very problem. We closed the fences when the cows were out. That's how we say in Italy. So it came out too late. So they anticipated the issue with AI and machines, issuing the EU AI Act. But that's not only one. So that's famous because it deals with AI, and Zuckerberg and others are getting upset because Llama has got some issues to come to Europe with that. But I think that will be solved without any big constraints. The fact is that the EU AI Act is part of a framework of regulations. There's a Cyber Resilience Act, which affects IoT wearables, not in medical or critical sectors, but wearables in any sector. Then you have the Machinery Act and the Medical Device Act, which addresses specifically machines in industry and machines inside equipments, inside clinics and hospitals. They're all coming together now as a mandatory regulation from the Commission, which will be embraced by 2027 by each single government in Europe. But as close as this is, to some extent, the EU has done a unique movement, which is the Data Act. Data Act is a different act, which is going to be all about the freedom of accessing data. So once you're getting data, you will be signing contracts with your automotive provider, with your washing machine seller, whatever, that your data goes to third-party players so that they can offer, let's say, insurances, payments, or even different services or different goods, because they do it better than others. So it's going to open up the market dramatically for services online coming from machine data. And literally, especially if you are a government, you've got rights to access any data. So if you've got BMW, which is actually tracking your driving style, BMW will not keep it per se. It will be obliged to give it to insurers and to other automotive players, because it's like the Bank Basilea, regulations from the Commission, which opened up the banking market because you were obliged to give the banking account data to the competitors. That's what the Data Act is regulating, and we do estimate that this will open up dramatically, as I was saying in the presentation, to the market for data monetization and data brokerage, especially if you are in the EnerTech, if you are in the smart cities and smart ports environments. Those data will be exchanged for brokers and value-adding service providers.
Thank you. Thank you, Fabrizio.
Thank you, Subbu. Appreciate that question. Any other question from the panel? Okay, I think this is a good time to move on to the product demo. Ricardo, please feel free to share your screen. And to the panel, please stop whenever you feel you have a question, you want to share your comments or ask questions. Yes, Sachin, please go ahead.
Yeah, I'm having one question, particularly with respect to this zero code solution, right? Can you explain the implication of this offering of zero code solution for the user, particularly when I talk about manufacturing companies? How does this empower manufacturers where we find varying levels of technical expertise?
Okay, yeah, very good question. So zero code means that the platform is able to plug and play any machine, equipment, appliance, which is using MQTT and OPC UA. OPC UA is a de facto standard which all the machines use. And you might not be using it in your organization. It's multinational and it's 30 years that is standardizing industrial machinery. And they have standards for anything from security to exchanging data machine to machine to getting the data. What is new is that during COVID, the Germans, which are very strong in this sector, were Industry 4.0 from Mrs. Merkel. She actually did a huge push towards interoperability of the machine market as for the regulations I was saying before. And the VDW, which is the world's largest OEM association, German, and VDMA, which is the world's largest mechanical engineering association, again, German, came together to define what they call Universal Machine Technology Interface. This UMATI is XML description of digital twins of machines. So there are more than 500 machines which have been standardized in terms of all their components and all their functioning, from robots to machine vision systems to lathe machines to printing machines to molding machines, you name it, you will have a standard there. We were the only non-Germans in the consortia, and actually what OPC did, they went to UMATI and they said, what the hell are you doing? You're not a standard body, you're a single nation body. But they were very smart because they gifted the specs to OPC UA, which embraced them overnight. So overnight, those 500 machines became companion specs of OPC UA. And today you have more than 500 digital twin semantics to interoperate so that you can take off the robot from Mitsubishi and put the KUKA one or the ABB one, and you will not change a line of code of all the intelligence back here. That's a huge improvement, because if you are a service provider, as soon as you unbundle the market so that you're not tied into a single vendor, the market would explode. That was the vision of the Germans, and now it's embraced by a world organization like OPC UA. And I'm lucky to say that with a patented solution, MYWAI is one of the first platforms, AI platforms for machines in the world, which is fully embracing the companion specs, not only the OPC basic specs that everybody's embracing.
Okay.
Thank you, Sachin, for the question.
One more question, particularly on this agentic control. So could you elaborate what is the concept of this agentic control and how it will help us to enhance the process intelligence as well as how it can increase the machine efficiency?
Yeah, we'll see all this stuff in the demo, which might be much easier. But as you see here, you don't read it. There's a marketplace in AI. This is the Stellantis solution, world-leading automotive. They've got a marketplace where internally they are developing toolkits and we are developing for them. And this is the quality agent. So this is an agent which is able to be trained, you see it here, on welds. So you tell the quality of this weld. Initially, the agent is quite dummy. It doesn't weld well, but as soon as you start doing some trial and errors, he learns, thanks to the fact that the Precitech welding head, laser welding head, has got feedback sensors. So it tells you if the depth of the weld and the penetration of the weld is going good or not. And so the agent learns. It's a transformer convolutional network which learns the quality that it's actually measuring live, and it feedbacks live to the welding power. So it's a real-time feedback loop where it's not a PID PLC driven interface in the traditional means, but it's an AA agent driving the welding laser. you know, you teach me that if this just gives you a 5 per million improvement of the quality of the battery, which usually blows up when it's not welded well, this pays for the, you know, on a single exercise to have an AI management system inside a large organization. So once it's in, you just do a domino effect and do all the other aspects of AI in the company.
Thanks, Fabrizio.
We'll see it in the demo.
Yeah, sure. Excited.
Let's move on to the demo, please.
Great. It's a pleasure to meet you all. My name is Ricardo Castagno. I'm a young business developer of MYWAI. I have the hard task to explain basically in 10-12 minutes what our team has developed in 15 to 20 years man of hardly an expertise in IT world. As you can see in the shared screen, what you're seeing right now is the dashboard, so the homepage of the MYWAI IoT platform that Fabrizio has been talking about to now, where you can see, let's say, some of the customers' machines that we are getting into, that we are hooking up and developing projects for them, always using the same infrastructure. So that is the main message that we wanted to share. Based on their basically location, you associate their, for example, for our coil manufacturer, it's a strip casting machine. Then we have in Genova some robotic arms or even ultrasound devices that I'll show you later. And then down at the bottom, we have a principle of a dashboard where you can hook up machines on real-time data. And this will be very easy to visualize with Stellantis, where we have actually a welding machine that is now performing for this demonstration. Now, going to the left on the panel, what are the key points? And I'm going to skip some of them. So then if you want to deep dive into more specific details, more than happy to schedule a follow-up meetings with you. The key point is that if you have a machine that is completely naked of sensors, or it's an old machine that needs to be sensorized, the key point is that you need to configure, right, your sensor. And since we are a multimodal based technology, what we can do is that we can accept acceleration systems, video cameras. And I'm just opening the first one where you see the measure, it's an acceleration. I define what is the frequency at which I receive the data points. I might be needing, like in this case, 40 milliseconds of data points, so very fast, or I just need it every second. I don't need it. It depends on the use case. And the key point that Fabrizio was explaining is that this part that is called the adapters, where this is the part that is responsible for attaching the sensors to the platform that is attached, of course, to the edge device, and enables the data flow from the field to the MYWAI platform. Now, what was actually the last question that was done by Sachin is the equipment type. So basically what Fabrizio and Sachin were discussing is that if an equipment, an asset, is dotated with the OPC-UA server, what I can do is just import as a plugin with zero code the tree formation of my equipment. And in this case, I just open the robotic arm, where you can see protocol type, you can see the axis type, and of each axis, I can see the actual speed, the position, acceleration. I didn't need to code anything for this. We just imported the semantic model of my robotic arm in a plugin way. And this creates me as well the possibility to define facets, for example, for dashboardings. I don't need the device health type. So if I know how to modify my schema, I can even highlight what I need and delete what I don't. Then once we have defined the sensors and what is the equipment in its general terms, it's time to configure the instances, okay? So here we have some of our customers' equipment, from underwater drones to cars to the welding machines to even pumps for water distribution. I'm just opening fast the robotic arm with OPC-UA, which is a POC that we did with Mitsubishi Electric. And by opening the tree view navigation, what I can see is the OPC-UA that I'm using basically to get the data flow from the robotic arm inside the platform. But in the case that I don't want to use the OPC-UA server for any regulation of any norms, I can attach, like in this other robotic arm, 3 acceleration accelerometers to register the vibration analysis. We're also working as well, as Fabrizio mentioned, to digital twins that we want to hook up with the data and have a perfect digital industrial metaverse at disposal. Now, I'm going to go straight to the fun part, which is the analyze, where we can do some analysis. Well, if I had a robotic arm attached right now, we would be having real-time data flowing inside the platform, and that will be the case for the welding machine. Or we can do, for example, historical analysis. So I'm taking, for example, a minute of acceleration of vibrational analysis for the Mitsubishi electric robotic arm. What you can see here is that there are 3 graphs because we're using 3 accelerometers, and each of them is registering basically 3 dimensions, X, Z, and Y. And of these, as a normal engineer, as a normal user of the platform, what I can do is that I can open it up, I can zoom in because we are a multimodal based infrastructure, and via timescale we can accept time series, and we can zoom in, see what is performing. I can highlight, maybe I just need 1 axis for this analysis. And once I see all this data, I might be confused like you, in the sense, okay, like, what is this data supposed to tell me? I can do 2 things. 1, if I know really that from this point to this point, the robotic arm is performing a certain activity, what I can do is that I can label it. I can call it, for example, demo day activity. And this is what the robotic arm is doing. I can then decide to, of course, define its color. I can define it every other label, and this constitute the intellectual property that is going to define how I maintain, for example, robotic arms. And I can decide to train my algorithms on these labels. Now, another interesting thing is that instead of doing supervised learning, so by creating my own labels, I can basically do unsupervised ones. So I'm applying, in this case, clustering algorithms that is basically defining, okay, I want to find 5 clusters of these window lengths, which are the data points basically that I want the algorithms to be applied. And as we are talking, this is a cloud-based infrastructure, so it's working with a CPU-based only cloud infrastructure. It took some seconds, but here we go. We have our 5 clusters. We can see here the green one. We can see here the red one, the blue one here, and it's just created automatically my labels. Here, the cool thing is that, okay, it's not Ricardo that, okay, these are the widgets, the labels for the predictive maintenance of my robotic arm. What I have to do first is to pass through a GitHub pipeline where I need to approve it or abandon my labels, so that then I can just certify my algorithm and push it, for example, at the edge, or I can run it on the cloud. To go more for example, images, we have some use cases. So Fabrizio mentioned earlier about ultrasound devices. We have an ultrasound use case with EthAum, where we performed anomaly detection. So we had to detect if the echographers were performing good for patients in Italy. You can see here there are some images. This one that I just selected is the good one. I'm sorry, it could be small, but these are the resolutions that is provided by the machine. And when I select them all and I run the algorithm that I train, what I can see is that I can select a list of algorithms which are imported inside the platform. I select the one that I need, which has its own trained model. I'm executing it. This is going to take just a few seconds. It's a very fast algorithm. And you can see here in the perfect image, there are no faults. While on the others, it successfully, unlikely, the defects inside the pictures. Then, once the algorithm is ready, where is it? Where is located the algorithm? It's in the algorithms module. So this is the part that Fabrizio was trying to really explain on how this is an AI management system where we can develop algorithms, third-party algorithms can be developed, even open source algorithm, like the one that I was showing, like Pix2Pix, the generative AI for the Itachi case, where you see the synthetic cracks. That's what we used. It's an open source algorithm that we imported inside the platform. Then, once it's ready, the algorithm, you have two choices. You can run it on the cloud, or you can run it at the edge. When you want to run it on the edge, you have the routine-based, let's say, method. Oh, I need to check my assets basically every week, every Monday, Wednesday, or Friday at a specific time with a specific time zone and intervals, and I need to report a Pankaj because my equipment has to be maintained. This is what the platform does. But in the case for industrial manufacturing plants, which requires more, let's say, technical logics inside the functionality, I can create a sort of RPA style robotic automatization where I can create jobs where okay, I'm getting a new node, for example, of 1,000, and the operator is detecting a value that is greater than 10, then I can activate some actions that can be an algorithm, it can be an MQTT, an OPC-UA, a sensor, or to continue my condition. This was a very brief presentation of what is the demonstration of MYWAI. Now, the key point is to go towards the welding machine so that we can answer most of the questions that were done. And this is what we are, a multi-tenant platform. So Fabrizio mentioned about Hilex, the sound quality controller, or even a Mitsubishi Electric that I just showed you, or even the EthAum. Now, what I'll show you here is the welding that we prepared for the tenant called Stellantis. So, as you can see here, it's always the same infrastructure. It's highly customizable, like configurable, pardon. So it's a white label software that once it's purchased, it's yours. You can see in the dashboard that there are some machines, basically some welding machines associated with always their locations. And we're going to run through 3 use cases. One, it's the welding machine that it's done on batteries. This one, it's the Fronis one on arc welding. And the last one is with the white bodies, car bodies, pot welding procedure. And this is the dashboard that I was mentioning you before. So these are data that are flowing directly from a machine right now that is performing welding procedures in a real-time environment. Now let's go directly to our equipments.
Ricardo, may I interrupt you?
Yeah.
I see that we have only 2 to 3 minutes left, and see if there are any quick questions or comments from the panel. Anybody, any questions or comments so far? Please feel free to unmute yourself. Yeah, Sachin, please go ahead.
Yeah, when it comes to this, particularly the computer vision solution you have developed in this application, so there's only one image on which you are determining whether the and you are just labeling that this is a good image, and then giving all the image, you can able to determine what are the defects are. So only with the one image we can able to do this kind of the analysis, or we need a multiple image model.
Very good question. That was done for EthAum, where we didn't say we have a digital signature of the probe. So the probe comes with a root of trust chip, which says I'm exactly probe number 2021-22 attached to that ultrasound. So the AI can learn the patterns even from the single image and detect the differences from the original product which came out from the manufacturing labs. That's one option. If you need to train on generic probes, obviously you need to give them a lot of images or many images depending on the difference across the images. And finally, there is PatchCore, which is one of the algos that we have uploaded from Amazon. It's open source. It gives you heat maps depending on the defect presence, but it learns only good trials. So you can teach the algo with good algos, with good samples, and he automatically learns the concept of good, and anything which differs, it can highlight it with a heat map. We didn't see it in the demo just for sake of time. Where what you're seeing now is a multimodal algo. So in this case, we are syncing we're syncing machine data, as you see here, with video streams. The video stream in this case, which was the question of Panasonic representative, we're just using it for backing up the synchronicity of the data, so it's not used by the algo. When you see it will start welding, the data will start being detected, and the algo is telling you this is an historical registration. It's telling you if it was good or not. And you know, this in this case, the video is just a webcam. But if you add a thermal camera, we are now adding a thermal camera, and that influences also the algorithm, a multimodal algorithm. But the good thing is that you can have hundreds of algorithms. You just upload them, and they work on the data, and they are distributed by the platform. So the platform is an AI management tool for multiple, let's say, scenes and scenarios and algos.
Thank you.
Okay.
Thank you, Sachin.
Any other questions? So maybe Ricardo can just go on with the demo underneath, but I can take questions. So without talking, we will just play with this, with the platform, while we take any other question you might be interested in. This is the agent that he's actually showing now. It's the welding agent, which is instead in the tool. There's a marketplace, and that black part has been nested inside the platform. So it's being completely designed for creating the agent, which is going to weld. It needs to be trained on quality. So there's a UX now where an expert of welds can actually teach to the agent what is a good welding quality. He's actually doing it by interacting with the interface. So it's saying that from these samples, these are good welds, and giving it a weight. So it's a weighted function that the agent can learn with reinforcement learning. And initially, it's welding not that good. But when it goes to a steady regime, because it's actually measuring the feedback from the sensors on the Precitech welding head, it's actually going to do a very good welding. So we can just see an end result and then close it there, Ricardo, just to see this is an historical weld where he is running the agent against the PID controller. The one that you see in reddish is the PID controller, where you see the power array is constant, whereas the greenish on the topper side, the top level side, that's the adaptive agent. So it adapts, you see, much more than the traditional PID. The resulting quality, which is the final line there, is the improved quality coming out from the adaptive agent. Okay, I'm conscious of time. I'll stop it here. Obviously, it's an enterprise system. It's meant for literally getting into the core part of, they're like a database management systems, an ERP, MS, a PLM. These systems will start crawling in large organizations. We are one of the world's first. There are a bunch out there, 10-ish more or less. You know, 3/4 are in the US, one is in UK, one is in Germany. And this is the last one which has come out, but it's much more standard-based and multimodal AI driven than the other ones.
Thank you, Fabrizio. I see that Chandan had to leave, and Vinod also have a hard stop. But yeah, I mean, it has been a fantastic session so far. We did talk about how AI is transforming the overall industry. So I think it was a fantastic, insights that we gathered today from the expert panels, and then we got some really interesting questions, intriguing questions on the solution from the panel. But yeah, if there are any other questions, please feel free to chime in, unmute yourself, and share your questions. And apologies that you had to leave because of your other engagements. But yeah, thanks a lot for your time today. Any last questions or comments that we may want to have during the session? Okay. Yeah. Again, thanks everybody. Appreciate your time. And I think this is just the beginning of this relationship. We need to probably reconnect again and see how we can collaborate, how we can support each other's initiatives, and take it from there. Yeah, we all are striving for a more efficient manufacturing space. Fabrizio?
Thank you, Pankaj. It's been wonderful to stay with you all. And yes, I mean, the actionable insights are there. We just need to pick them up and work them with AI.
Yeah.
Thank you.
Thank you, everybody. Appreciate your time and talk soon. Take care. Bye.
Bye.
Thank you. Bye-bye.